Oh my goodness, none of these are the ones I was thinking about. The math conjectures, what does it say over there, Hope?
It says the bigger the denominator gets, the smaller the pieces are.
So we've come up with this conjecture earlier. One more research we have that can help us, and you're gonna blow my mind if you're not thinking about the one I am now. Brooke, go ahead.
We can use a fringe line instead of.
At Ascend, we focus on deep conceptual understanding of mathematical concepts. So it's not enough for scholars to be able to arrive at an accurate answer. Instead, we want scholars, yes, to be able to arrive at an accurate answer, but also to understand the principles behind the math that got them there. Now what you find is kids who are able to solve problems with an understanding of what they're doing, and then we push them to take that understanding and apply it to procedures and conjectures and mathematical ideas.
Okay, good morning.
Good morning, sir.
Okay, I remember when my students derived the Pythagorean theorem by themselves, without me telling them. I gave them a scenario. After some work, we were able to realize that if they square the legs and they add the square of the legs, it would equal to the square of the longest side. And that led me to show them that they have actually derived the Pythagorean theorem.
There are three components of the math curriculum at Ascend. The first is Math Workshop, which is a workshop model where scholars are presented with really rigorous tasks, and then they work together or independently to solve those tasks, and then the teacher facilitates an engaging discussion that leads scholars to understand new ideas or conjectures about math as a result of engaging in that task.
My goal for my lesson today was to get scholars to reason more abstractly about fractions. We've been doing a lot of work with models, and students have gotten fairly good at that. That being said, it can be really hard to compare two fractions relying only on a model strategy. Sometimes one fraction might appear larger, but it's not actually if a model's inaccurately drawn. So today we are really pushing students to reason abstractly and use their thinking about those fractions compared to one whole to be able to compare them. Go ahead, Christopher.
Because the pieces are smaller in 7/8, it's getting closer to being a whole.
Putting this all together, what Christopher told us and using our models here, can someone give us their final answer for which is larger, 7/8 or 5/6? Jack Dillon.
I think 7/8 because Christopher said in 5/6 the pieces are bigger and in 7/8 the pieces are smaller. So in 5/6 since the pieces are bigger is a big chunk away from the whole, and in 7/8 since the pieces are smaller it's a small chunk away from the whole.
Whew, this is hard, guys.
The second component of the math curriculum at Ascend is number stories. During number stories, scholars spend an entire period focused on just one problem. It's a problem that relates to the world, and we're trying to build in our scholars an ability to solve real-world problems. So the teacher launches, the scholars study one problem, they attempt to solve it with a variety of strategies, and the teacher's walking around selecting a variety of strategies to share with the class, looking for varied levels of sophistication. The class then comes back together, and three scholars who have been selected share their strategies, and then the teacher again leads them in a discourse to discuss those strategies and again come to some big understanding or big idea about math. The third component of the math curriculum at Ascend is math routines. This is to build fluency in our scholars, and the idea here is to build an understanding of numeracy and to be able to add, subtract, multiply, divide, and to see relationships between numbers in a quick and fluent way.
What are some key features of a quadratic function on a graph? Yeah, like so here's a parabola. What could you tell me? What could you point at and name some stuff?
Open up of the graph.
Okay, what else?
The vortex.
Okay, what else? We're connecting all this stuff that we've learned, right? We have this transformation thing, and then we have factoring, and then we have completing the square, and then we have quadratic formula, and then we have zeros and roots, and I'm just trying to say, look, it's actually all under this big umbrella. We're making the connections between all of the different topics we've learned so far in this module.
We start the year with 4 weeks of professional development opportunities in the summer before teachers even set foot in the classroom. Then once they join the team, we offer weekly collaborative planning times on the grade teams called TPD meetings that provide teachers the opportunity to study upcoming lessons with their deans and their fellow teachers.
And we also found with B, we were really surprised when we looked at the student work at the misconception. And can you share what we found? Right, so we were just looking at some of the work and we're realizing that a lot of students are struggling with computational fluency, which led to them making mistakes, which is why they came up with the wrong product. And it wasn't that they didn't understand how to multiply a mixed number by a fraction, they were just making mistakes, which is what I also saw on everyone's paper on number 8.
All right, guys, thank you so much. This was awesome. We got to the bottom of a lot of really important misconceptions. I can't wait to see your work in classrooms next week as you review for the mock.